Vamos a seguir con la presentación de Christa Sommerer. Christa estudió biología y botánica y también pedagogía del arte y escultura. Habitualmente colabora con el artista plástico Laurent Millonneau y ellos son pioneros en la investigación y el desarrollo de sistemas de vida artificial e interactivos aplicados al mundo del arte. En la actualidad, ambos son profesores de Interface Culture en la Universidad de Arte y Diseño de Linz, en Austria. También imparten clases en Llamas, en Japón. Christa.
Thank you very much for the kind invitation to this festival and to this symposium. Thank you very much to Karin and Luis and Media Lab and the organizers. It's a big pleasure to be back in Spain, in Madrid. I've been here a few times. And I would like to show you a few works today that I think are relevant in terms of evolution of communication. And I've added a lot of things now since I've heard the previous discussion, so I hope I'm not over time. I'll try to go very fast. I would like to show you works that specifically focus on evolution and also the recent works which are here, mobile communications, and also show you a work that's in between these two systems that concentrates on nanoscience or principles of nanoscience. Laurent and me, Laurent Millonneau, we work since 1990 together, and we often apply artistic, we create interactive installations and often apply scientific principles to our media art systems. Specifically, we are working in artificial life since many years, in generative systems, for example, works like Evolve and Light Spaces. I show a small clip of Light Spaces. Also on complex systems, I did my PhD on complex systems applied to interactive art. And we have been developing many human-computer interfaces that are exploring intuitive and natural interaction. And I show you also work that is dealing with nanoscience. And this is a thing we are going to pick up, I think, very strongly in the future, as well as telecommunication. Just very briefly, we've been working with complex adaptive systems for interactive art since several years, and our aim there was to create emergence and novelty. As you know, there's this paradigm of that the sum is more than the mere accumulation of its parts, and systems that have a certain emergence are fundamentally novel. I'm going to speak a little bit about this later. Systems that we created in this sense let users experience or interact with them and create new forms of images or new sound outputs that are open-ended and somewhat between order and disorder. So there's certain kind of unpredictability and lack of control, and often the complexity in this system arises in the eye of the beholder. And let me maybe briefly explain what are complex systems. In complex system studies, the idea of emergence is used to indicate the arising of patterns, structures, and properties that are not adequately explained by referring to the system's pre-existing components and their interactions. This can be, for example, particles or agents, and as they interact, they display emerging collective properties, evolution, and critical behavior, and the system is fundamentally novel and not deducible into its mere parts. I don't want to go too much into details, but complex adaptive systems are often systems that follow these characteristics. They couple to each other, learn, adapt and organize, mutate and evolve, expand their diversity, react to their neighbors and to external control, explore their options, replicate and organize hierarchies of higher ordered structures. These principles have functioned for us as a kind of inspiration to create systems that are artistic, of course, but try to follow as much these principles. One of the systems we developed in '97 is called Live Spaces. Here, online users can type some text in a website, and this text is then transformed into little creatures that are kind of autonomous and start to live on a big screen that was installed in Tokyo at the ICC Museum, and users there could interact with these creatures, and the creatures also followed their own agenda. We encoded the text messages into creatures by following some kind of text-to-form editor, And each text then would lead to the same creature, while each different text would make a slightly different creature. So there was a guarantee that your text really makes a unique creature, and then the behavior of that creature would be strongly linked to its actual physical design. So you could have creatures that followed an agenda of adding energy, of eating, of mating, and there was an evolution going on within the system. I don't want to show this in detail, but mostly the creatures, after they were sent by the user, they consumed energy as they moved around, and as they lost energy, they had to eat energy by eating text characters, as you see in the little image. And by eating text, they could get stronger and start to look for a mating partner, and then mate with each other, and eventually create offspring that would carry on the genetic code of the other creatures. So what happened was an evolutionary cycle of creatures being born, moving around, motion, mating, and eventually dying if they run out of energy, and a sort of complex adaptive system appeared here. I show you a little clip here, if the sound works. I think I heard this cable has a bit of a trouble. Anyway, you see me here typing here some text, and as I type this text, instantaneously this creature appears on the screen, starts to move hectically around, tries to eat, and if it finds text to eat, it can get stronger and add up some energy. It doesn't really matter. I think I don't need the sound. Make it very short. Don't worry. To go a bit faster, in 2001 we were invited by the Volkswagen Stiftung in Germany to create a piece for an exhibition called Science and Fiction, which was shown at the Spreng Museum in Hanover and is now touring through Europe. The idea was here to deal with nanosciences and let users experience some aspects of the nano world, which is actually very difficult, as you know, the nano world is, or nanosciences is not really a field in itself, but a sort of accumulation of chemists, biologists, social scientists, philosophers who sort of explore the new possibilities of nanoparticles and the new materials and the new principles that come from this. And we were invited as artists to sort of reflect on these nanosciences, as you may put it, and create an interactive art piece with it, which was very difficult. So we decided to visualize the nano world through invisibility, and we created a sort of haptic feedback interface where users could touch invisible atoms. And by letting users feel these atoms, they sort of would start to understand or experience the complexity of the nano world, at least to a certain degree, or very metaphorically. Here's a system setup. You see the users wearing these magnetic ring interfaces, and as they move their hand over the table, they experience some very weird and strange forces of strange attractions and repulsions. And as they move their hands, they can feel that they change this behavior of these invisible things or atoms. And inside the table, we have magnetic force feedback interface consisting of electromagnets. Each magnet creates around 6,000 Gauss magnetic field, and this magnetic field is changed through the user interaction. On top of these tables, you have a camera tracking interface that tracks the position of the user's rings on the hand and coordinates the position and the movement and strength of the movement with the magnetic field produced by these electromagnets. And here we see the permanent magnetic ring that's worn by the users, and the camera tracks this. You can see here an image. There's a camera here, infrared light source to detect the markers, projection screen, here the electromagnetic coils that go to the interface, and the computers which run the atomic force simulation software. the atomic force simulation was modeled on no valence electrons. I'm not sure if that goes really too much into details, but these are usually atoms that have form solids, and based on Cassira's descriptions, atoms that have electronic shells completely filled, which in gaseous form are very inert chemically. And these kind of atoms, their main target is to have as many neighbors as possible. So they try always to negotiate their place and try to have a kind of equilibrium state where they accumulate as many neighbors as possible. So we created a 2D simulation of around 120 atoms that follow the simplified simulation of the van der Waals forces or van der Waals interactions, where each atom, as you can see here, tries to negotiate a kind of equilibrium and equal distance to all the other atoms. And as soon as this system gets disturbed by the user, which is represented through this red dot, that's actually the hand position of the ring, the system gets out of order, becomes chaotic, as each of the atom is linked to the other atoms and tries to renegotiate and go back into equilibrium. So what happens from this tiny little interaction, a kind of complete disruption of the system, where the atoms try to constantly change back to the initial states. And this is actually what the user can feel. So the user can feel the magnetic feedback of his own atom, which is here as represented as a red dot, and he can feel the forces onto his atoms from all the other atoms around it. So, for example, if you interact very strongly, you get maybe a very strong kind of repulsion or kind of strong force, while if you interact very weakly, that interaction might feel very weak. All 4 users interact also at the same time, so you see this in the simulation. There are 4 users here now. This means the more users interact and the more widely they really interact with this invisible shape, the more complex the whole behavior of the shape becomes. The simulation is not really shown to the user, it's outside on the monitor, as we found out that it completely disturbs the haptic sensation. So it was very abstract, and the kind of shape that appeared from this simulation was actually only a mental shape that the user could feel when they interacted with it. So I think what was interesting in this experience is actually, even without any images or without any visual feedback, you can very well make a mental image of a kind of shape or a kind of haptic communication between people. And we decided to explore that further. Here's a little, it's not necessary to have sound, it's in German, but you see Laurent and me here touching this shape, and after a little experience you can also really kind of touch each other, because if I touch my atoms and disturb them, then I can make Laurent feel this interaction. So it's a kind of very strange form of communicating to each other via touch, even though it's a kind of virtual touch. This experience gave us the idea to explore the sense of touch further. As you know, the touch sensors cover 80% of the human body, and we have a very sophisticated and differentiated knowledge of touch. Like I know very well how this Macintosh feels, I know how this plastic feels, I know, how this glass feels. So we have a lot of intuitive knowledge about touch. Touch is very direct, intuitive, personal and private. On the other hand, there's very little, it's very difficult to share the sensation of touch verbally with others. And in fact, there's not really a classification scheme or measurements or scales of touch. There are some attempts by Heller or others, but considering that human communication is not only based on exchange of visual, verbal or auditory information, but also on the exchange of emotion, we decided to explore this a little further and create systems, mobile communication systems that explore the sensation of touch. We did a little research. I'm sure many people of you know the work by Stahl Stansley and Kirk Wolford. who in 92 devised the Cyber SM bodysuit, where connected users in Paris and Cologne could touch each other by touching their sort of cyber suit and feel this sensation over distance. There's also Naoko Tosa, who did a networked neurobaby, I believe in 95, where you could shake hand in Tokyo and feel that kind of shaking motion in Los Angeles. There's of course Stellag with his ping-pong protoparasite body, where online users could remotely interact with Stellag's body by activating sensors, motors and actuators that were attached to Stellag's muscles and extremities. There's lots of research going on in affective computing, affective jewelry and wearable computing. I don't want to get too much into this. But our main focus in developing this touch telephone, which is here on display, is to create a system that explores this intuitive communication of sending touch over mobile networks, and also in this way explore issues of privacy in an age of increased connectivity and sharing of information. And see how this kind of, giving up your last corners of privacy and sending and broadcasting it out to strangers, what kind of effect that would have on people. This is actually the second version, but it's the same technology. There is different sensors, actuators integrated into these objects, and as users hold these objects, here in this version we have girds or calabas, I think in Spanish. The user's heartbeat is detected and sent to the connected user, who can then feel the heartbeat through actuators and motors in his hand. So there's a direct exchange of haptic information via pulse sensor, press sensor, motors and micromotors, microventilators, LEDs for visual feedbacks, and we programmed our own firmware and used a Bluetooth communication device. So the sensors capture the user's heartbeats and send it to the remote users. Actuators and motors relay that information as an actual pulsing in the hand, so it really totally corresponds to the signals that come in from the heart of the other user. And in addition, there's a little breathing sensor or kind of heat sensor that captures the breath of the user and sends that information to the other user, where that information is relayed into a little wind that comes from a small microventilator. And all this communication is done via Bluetooth network. Experiences that we made with this system is creates a strong sensation of intimacy. I still actually feel all the people I did yesterday's experiment with. So by seeing a person and then actually feeling his or her heartbeat, you get very different knowledge about the person. And it's sometimes very surprising that the actual physical the look of a person does not correspond at all to what his heartbeat or his or her heartbeat might be when you just look at them. So I think there's also very embarrassing, ambiguous and erotic type of communication going on. And I think there's some kind of, even though it's very unscientific, but I think there's some personalities of touch. I think there's some different categories of people and their heartbeats, whether it's fast or how fast they react. Maybe it depends on how fit they are or how much sport they make, or I don't know. I didn't really study that very carefully, just intuitively. What we also observed is that when you interact with the systems, your other senses shut down. You don't really talk so much, or you don't really concentrate so much on vision, but you try to experience the sense of touch. It can feel very relaxing and comforting. And it creates definitely a kind of externalized presence, where you feel like someone has given you a part of himself or herself, and you can share that. Here's a little situation from an exhibition in Germany, where it was shown in these egg-shaped interfaces. And I think since you probably have seen it, I should just show you the version that is on display here, which is actually the first version. Here we integrated it into very abstruse organic objects like girds, And the idea here was to challenge the mobile communication metaphor, to go away from the slick and aesthetic and technical and bring it into the bizarre, mythological, surreal or absurd, and combine the organic with the digital. And I think it was shown at Ars Electronica in 2003. Not everybody really understood this work, but I think it did create a kind of strange sensation of linking something that has very much sophisticated technology into these very organic objects, created a very strange, ambiguous situation. And maybe reminded many people to something very primitive or, I don't know, private or very intuitive. And also the sensation of blowing into someone's face over distance, I think, is also very, very, very weird. So let me summarize. We explore systems that explore scientific principles, and we try to build them into artistic, interactive experiences. We often design natural and multimodal interfaces that create intuitive interaction experiences. We apply artificial life complexity and recently begin to explore nanosystems for interactive art to create open-ended and nonlinear systems. And we are trying to create systems that are open-ended and take the user's personal interaction parameters into account and explore also the sense of touch. I think this slide I didn't completely check first. But by looking into nanosciences, we are interested to explore new artistic expressions, tools and materials that are not really there yet, but have yet to be invented and imagined. Or as Drexler, the famous nanoscientist, writes, strange futures lie open, holding worlds beyond our imagining, that not only should become engines for innovation for scientists, but to artists alike. Thank you very much for attention. And if you want to contact me, it's Christa at Yamas, AC Japan.